Okay, for question number 3, a twist of a 4 Newton meter is applied to the handle of the screwdriver. So we have this one, which is this one, applied at the handle of the screwdriver. Resolve this couple moment into a pair of couple forces F. Exert on the handle P. And P exert on the blade. So F is at the handle, so this is handle, and this is blade. So we have at handle 4 Newton meter. So we have 30 mm of distance, and this is F. The total of moment is equals to F times 0.03 meter equals to 4 Newton meter. So we have F is equals to 133 Newton. Okay, and then we have P. So we need to calculate moment at P. So we have at P 5 mm, and we have P. So the a blade, okay, so for the blade it is equals of torque or moment, okay, which is we have also 4 Newton meter. When we apply at the handle, so 4 Newton meter will be applied at the blade also. So now we have 4 Newton meter P times 0.005 meter is equals to 4 Newton meter. So we have P is equals to 4 divided by 0.005. P is equals to 800 Newton. Okay, so we have calculate our P, and we have calculate our P and F, sorry, P and F. Number 4, so question number 4, the ends of the triangular plate are subjected to 3 couples. So 1, 2, 3, 3 couples. Determine the plate dimension D, so D is what? So that the resultant couple is 350 Newton meter clockwise. So clockwise, 350 Newton meter. From this one, we need to find our point. Okay, so we just put here as A. Okay, so we want to calculate our moment at A, depends on our force given. Okay, so from the figure, okay, so if we find A, moment at A, so this force will be cancelled because there are no distance. Okay, there are no distance, so we cancel the 100 Newton and 200 Newton force, and also this one because it is acting on the line, and then it is touching point A. Okay, so there are 3 force that will be calculated in this questions. Okay, so we have 100 Newton meter, which is perpendicular, okay, with this. So we just can calculate that one directly because it is 90 degrees perpendicular. So the distance for 100 Newton force is D. That is the distance. And then we need to calculate our distance for 600 Newton. So we have 600 Newton. This is the action line from O, and this is the force. So 600 Newton, and this is D. So D2. So we have D1. Okay, D1 is here lah. It is the same. So D1 is actually D sine 30. Okay, and another force, that is the first one is 100 Newton, and then we find our D for 600 Newton. Okay, so last one we have our 200 Newton force. Okay, this is 200 Newton, and this is our D. So D for 200 Newton is equals to D cosine 30. Okay, so it say that from the question, it is the resultant force, assume that sigma of moment resultant is the at A. Okay, so the resultant force at A is clockwise 350 Newton meter clockwise, equals to, so we have the first one 100 Newton meter times D. Okay, 100 Newton meter times D, and then actually it is moving counterclockwise. Okay, this one is sorry, clockwise, so it will be negative. Okay, so next we have 600 Newton. Okay, so 600 Newton is also clockwise direction, so negative 600 Newton times the distance is D1. Okay, D1 is times D sine 30 degree. And then finally we have the 200 Newton force. 200 is acting counterclockwise, so this one is positive, plus 200 Newton. The distance is D2 D cosine 30 degree. Okay, so you need to solve the equation, and then finally you will get that D is equals to 1.54 meter. So solve this one. Okay, alright, so question number 5. Okay, we have question number 5. Replace the force and couple system by an equivalent force and couple moment at point O. Okay, it is quite confusing. So we need to calculate at point O. Okay, so this is our point O. So what should we do? We need to break our force into X and Y. So for 6 kilonewton X and Y, and also we have for 4 kilonewton X and Y. Okay, so I just tak nampak. X, Y and X. Okay, so and then we need to calculate our force of X and Y, and then we need to calculate our moment at O. Okay, so now we go for 4 kilonewton X direction, we have 4 cosine 60, and this is 4 sine 60 direction. For x direction, we have 6 kilonewton times 5/13. And then for this one, we have y direction, we have 6/12/13. Okay. All right. So for fx positive is equals to for fx positive, we have 6 5/13. Okay, minus 4 cos 60 degree. Okay. All right. So we calculate. Use your calculator, and then you can get 0.30769 kilonewton. Then for Fy up is positive, we have y 6/12/13. This is positive, and then negative 4 sine 60. Okay, then we can get 2.0744 kilometer. So we have x and also we have y. So for the resultant force, we have 0.30769 square plus 2.0744 square. So we got our force is 2.10 kilonewton. Okay, 2.10 kilonewton and theta. Okay, so we have theta is equals to tangent 2.0744 minus 0.30769 equals to 81.6 degree. Okay, that is the resultant force. Now, for the moment at O, okay, so for moment at O, we have 8 kilonewton meter. Okay, that one is the first one. This is from O. We have break our force, okay, that will calculate into the equation is this one, 6/12/13, and this one is 6/5/13, and this one 4 cos 16. Okay, 4 sine 60 is not calculated because it is on the line O. Okay, so we calculate our force. Counterclockwise is positive. Moment at O is equals to 8 kilonewton meter counterclockwise. That one is positive, 8 kilonewton meter. So at O, okay, so we have this one. Okay, so this one, the acting line is here. So the line is 6/12/13 times distance is this one. Okay, so this is 4. Right, so that one is 4 meter. So we Okay, before we continue to calculate our equation, our moment, we need to define which is positive or which is negative. So we have a clear vision on how our force act on our structure. Okay, so for this one, we have 8 kilonewton that move counterclockwise. So this one is counterclockwise direction, so it is positive. And then we have 6, this one, okay, 6 times 12 over 13. When we fix at O, it is moving clockwise direction, so it is negative, so clockwise direction. And then we have 6 times 5 over 13. If we fix at O, it will move counterclockwise, so it is positive. And finally, we have 4 cos 60. If we fix at O, it will move clockwise direction, so it is negative. So we count for the positive. So this is 8 kilonewton meter. Don't forget that moment is a force times distance. So then we have the positive one plus 6 over times 12 over 13, and the distance from O for this one is this one, 4 meter times 4 meter. And then we have counterclockwise, so this is negative, counterclockwise, and the distance for this one, okay, the distance is, this is the reaction, the action, line of action for the force, and this is the distance that at perpendicular. So this one is 5 meter. So we have negative 6 5 over 13 times 5 meter. Okay, this is distance, and also we have negative 4 cos 60. This is 4 meter. 4 cos 60 times 4 meter. Okay, so that is our moment. So from that we can use our calculator to calculate, and then we get moment at O is equal to 10.62 kilonewton meter, which is 10.62 kilonewton meter clockwise direction positive. Okay, so this is equivalent force and coupled moment at point O. So that is the moment. So number 6. So the final question: replace the force system acting on the beam by an equivalent force and coupled moment at point A. So point A, and we need to break our force. Okay, so we have this one, 2, 3, 4, and that's it. So we need to calculate in X direction and also in Y direction. So for X direction, we have positive Fx direction is equals to 1.5 kilonewton in X direction sine 30 degree on the right direction, positive, minus 2.5 kilonewton times 4 over 5. So that is our Fx, and we need to calculate our Fy. Fy, we have going up positive, but all of our forces is acting down, so negative Y, and we have, for the first one is negative 3 kilonewton minus 1.5 kilonewton cosine 30, and also we have minus 2.5 times 3 over 5. So we get from the calculator, we can calculate, and we have the answer negative 1.25 kilonewton. So it is 1.25 kilonewton to the left. And then for Fy, we have negative 5.799 kilonewton, and it is actually 5.799 kilonewton acting downward. Okay, so we have 1.25 to the left, 5.799 kilonewton. So the resultant force, Fr. Okay, so we have Fr, and then we can calculate our theta. This is our theta. So if the question is from x direction, so you need to add 180 degrees plus theta. Okay, so Fr is equals to 1.25 plus 5.799. Okay, if you want to put negative also again, because negative square will be the positive answer also. So Fr is equals to 5.93 kilonewton, while the theta is equals to 77.8 degree. Okay, so that is the equivalent force. And now we want to calculate our moment. So moment at point A. So we have moment at point A. Okay, so moment at point A, we assume as there are no given distance here. So the force of this one is not be calculated because there are no distance given. But if they include the distance of 0.1 meter, let's say, so you need to calculate from the point. Okay, so for this one, we need to calculate at point A. So moment at A. So which force that will act to the moment of A? First for this one. Okay, so we have 2.5 times 3 over 5. And then we have this one, 1.5 cosine 30. And this one, 3 kilonewton. So the distance is 2 meter for this one. 2 meter, and then this one is 2 plus 4, 6 meter, and finally we have 8 meter. Okay, so summation of the moment at A, okay, counterclockwise is positive, is equals to all of the forces that acting on the beam will make it a clockwise direction. So this one is clockwise direction, this one is clockwise direction, this one is clockwise direction. If we take point at A, okay, so all calculation must be in negative. So for the first one, we have negative 2.5 3 over 5 times, this is the force. Don't forget to put the distance, which is 2 meter, minus 1.5 cosine 30 degree, This is the force. Don't forget to put the distance. Distance is 6 meter minus 3 kilonewton times 8 meter. Okay, so from calculator we calculate, the answer is 34.8 kilonewton meter is equals to 34.8 kilonewton meter clockwise direction at point A. Okay, that's all for our tutorial number 2. Thank you very much.